Hi, these are the instructions to set up a VariantSpark cluster on Amazon EKS. You can see here are the instructions on GitHub. There are a number of one-time only client steps that I've set up already. I've also set up the configuration with the size of EC2 instances I want to work with. So I'm going to scroll down. I'm going to start from this infrastructure directory and open a terminal. And then I'm going to apply the first command. I've already done Terraform init one time. You only have to do it the very first time. And you can see there'll be 57 objects created. So now I'm going to have those objects be created by running Terraform apply. I'm going to wait. This can take from 5 to 15 minutes depending on how many objects you're creating, how many EC2 instances. So I'm going to pause the video and come back when this is done. Now that this is complete, we're going to go ahead and configure Kubernetes. We're going to apply this YAML file. And now we're going to start the proxy so we can connect to the dashboard. It takes a couple of minutes for the authentication to propagate, so I'll connect and we'll probably see an error when we first start. Yeah, so let's give this a minute and then we'll come back once this is authenticated. So now this is authenticated. And now we're going to open a new terminal window. And we're going to set up one of the pods as a persistent pod for Jupyter by applying this YAML. And in the dashboard, when we refresh, we'll first see an error, and then the pod will turn from red to green as it propagates. So now this has turned green, and so we're going to go ahead and work with this. I'm just going to make this a little bit bigger. Now to connect to the Jupyter Notebook instance, we need to go into the pod, and from the log we need to retrieve the token. So we're going to copy that. And then we're going to click on the Notebook Client Service to get the endpoint. And we're going to paste the token in. And now we're going to upload some sample notebooks. These notebooks were designed for performance testing, so they just invoke the command line. And we'll start with a small one. You can see I've documented some information about the run inside of the notebook and about the parameters. Now if I scroll down, and we'll be using data from the input bucket shown on line 6. Now on line 29 through 46 is our Spark submit command. And you can see here what we're doing is we're creating a job on our cluster that is using 6 Spark executors. This is on line 36. And then the VariantSpark parameters are on lines 39 through 46. We're calling the importance analysis using the VCF input file and the label file on 40 and 41 with the feature column name listed on 42. On 43 we're using verbose output. The RN parameter is configured to 500 and the RBS is 16. And the RO is configured on, and that's the out-of-bag error indicator. We click in the cell, and then we click Run. Now when this is running, you'll see that initially we have only the persistent pod, but because we requested 6 pods, they're going to be initiated in the job run. And I'm just going to click refresh so you can see the pods. So there we have the driver pod for Spark. And there we have the worker pods. So we've configured 6 pods, and the version of Spark we're using is designed to work with Kubernetes 2.3. Now these pods run on nodes, so if we go over to the nodes section, you can see that we have nodes for each of our EC2 instances. We have 4 instances configured here. Now we can look at the resource allocation usage if we click on the node name. So you can see here's the CPU requests, limits, and the memory. We click in. And of course what we're trying to do in our sizing is we're trying to allocate the appropriate number of EC2 instances, Kubernetes configuration settings, and Spark settings and VariantSpark settings. So this is a real small job. It's just designed to kind of hello Kubernetes test to see if the cluster is working properly. Now while the job is running, we don't get any feedback from VariantSpark itself. The only indication we have is this hourglass. This is still running. And if we go back into the overview, you'll see now all the pods are green. So we have 8 pods. We have the notebook client, the driver, plus the 6 requested worker pods. Now during the job run duration, these pods will be working. When the job is complete, the pods that are workers will stop. They're no longer needed. And then the result of the analysis will be available on the driver log. So I'll pause the video to wait for this to complete. And you can see now the icon is turned back into the book, so this is complete. And if I refresh, you can see that the pods are shown as completed. And I look at the log of the driver and scroll up. You can see here's our OOB accuracy, here's our time, and here's our output. Now when we're done working with this, we just go ahead and close this, shut this down, close this. I'm going to make this smaller again. First thing we do is we delete the persistent pod for the notebook. Then we stop the serving of the Kubernetes website. We run Terraform plan destroy. And then we run Terraform apply to apply the destroy. Notice it's going to destroy 57 resources. And it's really important that you wait for the destroy to complete because there are resource dependencies. So I'm actually going to pause the video and then I'm going to show you what it looks like when it's successfully destroyed. If you get in a situation where the destroy is not complete, you may have to go into your Amazon account and manually look for and delete resources. Those are usually in the VPC or the EC2 areas. And once the destroy has been completed, you should see this apply complete where there are 57 resources destroyed. And then in the future, you would just run Terraform plan and Terraform apply and then add the 2 YAML files to reestablish the cluster.